Probability example 36b. There are about 100 sunny days per year in Ketchikan, Alaska. Hope I pronounced that correctly. Making the probability it's sunny on the day you visit 2700ths. You are spending 7 days in Ketchikan. What's the probability it's sunny at most 5 of the 7 days that you're there? So is this a binomial probability? Well, it's either sunny or it isn't. Okay? And we're also making the assumption in this case that it's independent. So when we're saying at most 5 of the 7 days, at most 5, that means that our maximum is going to be 5 sunny days and our minimum will be 0 sunny days. Or funny days, I guess it depends on how you spend your time. So we're looking at the probability of 0, or the probability of 1, or the probability of 2, or the probability of 3, or the probability of 4. Oops, I forgot my P there. Or the probability of 5. Okay, that is a lot of probabilities to add. So this would be called the direct method. So maybe you would like to try the not method. There would be 1 minus, okay, you're going to be there 7 days, so what probabilities are missing? So we have 0, 1, 2, 3, 4, 5, so we're missing the probability of 6 sunny days and the probability of 7 sunny days. So we would have to subtract both of those probabilities from 1. Okay? All right, so we're going to have 1 minus, okay, we had 7 sunny days. We're looking for 6 successes. So the probability that'll be sunny is 2700ths raised to the 6th power. So the probability of it not being sunny, well, you'll take this away from 1 and we would get 7300ths. Okay, so if this is 6, we have 7 total trials. This will have to be 1. And then minus probability of 7 sunny days. So 7 days, see 7 successes, 2600ths to the 7th power times 7300ths to the 0 power. And when I put that in my calculator, I get 998 thousandths.